Okay, I've got scatter graphs here for 4 different possible data sets. I'm not going to indicate what these data sets might represent at this point. We just want to look at the general idea of a scatter graph representing a data set, and we want to see if that scatter graph plausibly represents a power function, or maybe an exponential function, or if there exists a transformation or a sequence of transformations that will give us plausible power or exponential functions. Better stated, for which the graph would then represent a plausible power or exponential function. So, the first thing you need to do is look at these graphs, and don't look ahead because in a minute I'm going to sketch some curves. Sketch the curves you think best represent the trend of the data for each of these graphs. You should pause and do that. But I'm going to go ahead now. So I'm going to go ahead and going to use an orange piece of chalk to indicate what I think might be the trend of each graph. Okay, so there's one. And here's another one. And down here, the X on the origin means that the origin is a data point, or is expected to be a data point. And you want to be careful about whether you actually make that assumption or not. So there's a nice curve. And over here, well, I kind of messed that one up. That curve's a little bit too high, but we still get the idea. Okay, now, is it plausible this is a power function? Okay, well, we can pick a series of x coordinates, each doubling the preceding, and seeing if the value of the function changes by a constant factor. If so, then we would say that this is plausibly a power function. If not, well, we can shift this graph. We can raise it up or lower it a little bit, move it a little bit to the right, move it a little bit to the left, and maybe then it will become a power function. Or maybe we flip it around. Now that would involve officially reflecting it through the y-axis, then moving it over and moving it down so that it goes this way, and maybe then it would become a power function. And maybe if we put it in the right place, it could become an exponential function. So you can think of different ways to transform it. Now I'll draw a few possibilities. Okay, if we shift it to the right and lower it a little bit, maybe it's going to end up looking something like this. Okay, could that be a power function or an exponential function? If we flip it and translate it so that this point here becomes the origin, maybe it's going to look like this, and maybe that's going to be a power function. Okay, maybe it's an exponential function, so maybe if we just drop it a little bit, maybe it's not an exponential function, but if we just lower it a bit, maybe it'll become one. So if we just lower the graph, so it might look more like this, maybe that's going to be an exponential function. Now, I haven't done a very good job of drawing those possible curves, but those are all possibilities. Okay, so we could do similar things to these other graphs and test whether there's a way to transform it that appears to make it into a power or an exponential function. Of course, we should know what the tests are. And this course involves some practice. You try different versions of the graph. Make sure you construct them accurately. And just see what happens. You'll get a feel for it, and you'll get a better feel for what a power function looks like, what an exponential function looks like, and for what the characteristics of those functions are.